Okay, chapter 7, day 3 video. What we're going to focus on today is how do we solve equations that have uncommon bases raised to some power. The bases will not be the same, okay? And so you'll recognize these problems once you see them and get used to them. Right now you might not know what I mean, but we'll get into it, you'll be fine. Note, all right, so let's say I have x raised to some power a and x raised to some power b. If someone says that these are equal, the only way that they can be equal is if the power on this x is the same as the power on this x. So if x to the a equals x to the b, then a must equal b. It's the only way possible. Okay? If these have the same base, all right, then the exponents are equal to each other. I wrote that down right here. So, if the bases are the same, then the exponents must equal each other. You might say, well, wait, I thought you were saying we did uncommon bases. We are. We're going to start with uncommon bases. But our goal is to make the bases the same, so that way we know that the exponents are the same. So let's take a look. If the bases are not the same, then you must find and create a common base. So that's going to be our task, is to find a common base and make the problem into a common base. So let's take a look at a problem. So problem might start out, it might say solve for x. Okay? So here's the problem. 2 to the x plus 2 equals 4 to the 2x minus 5. These bases are not the same. So the first step, we have to look for a number that can be raised to a power and get both bases. So I have to think of a number that I can raise to a power that would be equal to each of these bases. But the number that I'm raising to a power has to be the same for both. Okay? So it can't be any bigger than the smallest number listed. All right? Well, let's start out with 2. I can write 2 to the second power as 4. All right? So what I can do is I can take this and put it here instead. Actually, I'm going to do this and replace this with it. All right? Now, this has a base of 2, and this would also have a base of 2. So therefore, 2 is my common base. I can rewrite 4 as 2 to some power. 2 is, I don't need to rewrite. Okay? So, look for a number that can be raised to a power, and to get both bases need to be the same. So my base of 2, this would also have a base of 2. We're okay. 2 is my common base. So, step 2. Rewrite so that both bases are the same. So I'm going to rewrite. If I'm not going to change the base, I'm just going to write what I have. This one, instead of 4, I'm going to write 2 squared. It's the same thing as 4, but now the base will be the same. All right? This, 2x minus 5, is still the power on 4. It doesn't change. I'm just rewriting 4 as 2 squared. That way my base of 2 is the same. All right? I need to clean this up a little bit, because a power raised to a power, we need to take this 2 and we need to do some distribution here. So let me clean this up a little bit. So this turns into, this doesn't change over here, so this is 2 to the x plus 2. 2 to the 2 times 2x is 4x, minus 2 times 5 is 10. I'm just using my power to power rules, which means multiply the powers. Notice, my bases are the same. So, if we go back up to the very beginning, what did we say? If the bases are the same, then the exponents must equal each other. Well, here we go. My bases are the same, so therefore, these two pieces here must equal each other. So step 3, drop the bases or get rid of the bases and solve just what is left for x. So this, x plus 2, must equal 4x minus 10. The bases are gone. So now I take what's left and I solve for x. If it's linear, numbers on one side, letters on the other. If it's quadratic, gotta have to factor it. If it's not factorable, you have to use quadratic formula, complete the square, anything like that. So I have a 4x and an x, so I'm going to take away an x. So now I have a 2 equals 3x minus 10, add 10, add 10. So now I have 12 equals 3x. Divide by 3, and x equals 4. And that is my answer. I could check it. 4 plus 2 is 6, 2 to the 6th power. Okay. 4 times 2 is 8, minus 5 is 3. 2 squared to the 3rd power is 2 to the 6th. 2 to the 6th is equal to 2 to the 6th. All right. Let's take a look at another problem that we run into. Okay? Notice in this situation, my base of 4 and I have a base of 8. Again, I'm going to start with my low number. Can I write 8 as 4 to some power? No. So I have to think of a number smaller than 4 and 8 that they can be written as some power. And again, 2 will work here. So 4 is 2 squared to the 2x. 8 is 2 to the 3rd. So you're going to have to memorize and be familiar with the common powers that I put in the last video. So now what do we have? We have 2 times 2, that's 4x, equals 3x plus 3. I don't even need to write the bases because they're the same. So bring the 3x over, and I get x equals 3. Done. So again, if the bigger number can't be written as a power of the smaller number, you have to think of a number smaller than both of those yet that you can raise to a power. One last one we'll take a look at. So, do a little solving, take away 3, 7 to the x minus 1 equals 7. This is to the first, even though you don't see it. Hey, bases are the same, so x minus 1 must equal 1, x must equal 2. So you can put this into an equation, and as you solve the equation, you still could end up with common or uncommon bases. So we're going to do a bunch of these in class.